Hello everyone, let's discuss the given solution. Now, first let's read the question. The question states that if for a positive integer n the quadratic equation this is equal to 10n, then we have to find the consecutive integral solutions for the value which n may hold, right? The equation is x into x plus 1, x plus 1 into x plus 2, going on till x plus n minus 1 into x plus n equal to 10n, right? To solve this question, we need to understand one thing, that is uh, when we say we have three terms, let's say four, how many number of pairs can we make when we have four given terms? The number of possible terms consecutive, that would be 1, 2, 3, right? In case of 5, it would be 1, 2, 3, 4. If you can see the pattern, n is equal to 4, number of pair is equal to 3, n is equal to 5, and number of pair is equal to 4. That is one term less than the total terms, correct? So when we say in the equation that we had x plus 0, x plus 1 plus x plus 0 into x plus 1 plus x plus 1 into x plus 2 plus x plus 2 into x plus 3 till the last term, we have total n terms, correct? So when we multiply the brackets and rearrange them, we get the following equation. First we get n terms of x square. I hope you'll agree with that. Now the second, when we multiply x plus a into x plus b, we get the second term as a plus b into x, right? I just write it down here, x square plus a plus b into x. The third term is ab, right? So we get n, first term is x square, we get n x squares. Now in a plus b, for the first bracket, the values of a and b were 0, a was equal to 0 and b was equal to 1, so 0 plus 1, 1. For the second bracket, it was 1 plus 2, that is 3. Third bracket, it would be 2 plus 3, that is equal to 5. Similarly, we reach up to n minus 1 plus n, that gives us 2n minus 1. This whole summation into x, that is here. Now the third term is ab, 1 into 2, 2 into 3 till n minus 1 into n, correct? Yeah. So this is all equal to 10n. Further simplifying this, uh, we know the sum of first for such a series is this, n minus 1 into n plus 1 divided by 3. Okay, and for first n minus 1, sorry, first n odd numbers is n square by x, correct? What we do is divide n on both sides. We cut an n from here, n from here, and n from here, leaving only 10 on the other side, right? We take 10 on the left hand side and calculate it with this term, giving us the value x square plus nx plus n square minus 31 upon 3. Mind that n square minus 3 is only dividing n square minus 31. It is a constant term in the last. Now we know the difference between roots is equal to 1. How? Because uh, alpha minus beta is equal to 1, that is d equal to 1, right? So n square minus 4 by 3 is equal to n square minus into n square minus 31 equal to 1. If you solve this equation, you'll find the value to be n equal to 11. Hence our answer is n equal to 11.